Hello everyone, the topic for this video is powers with negative rational exponents. Let's begin by looking at some examples with negative exponents, then we'll move on to negative rational exponents. First example, 4 to the power of negative 3. Alright, so a negative exponent is really telling you that the power isn't in its natural position. Now, position-wise, I want you to think of really just two positions, a top and a bottom. So top and bottom. So if it's not in its natural position and it's in the top, that means the natural position must be the bottom. So what we'll do is we'll move the power to the bottom. When we move the power to the bottom, now that it's in its natural position, it doesn't need the negative sign anymore. So the negative sign is really a signal that this power is not in its natural position. Now for a number up top, we can't put a 0 because that would mean there's nothing, so a number that won't affect anything would be 1. So we'd go from 4 to the power of negative 3 to 1 over 4 to the third power. Once we have taken care of the negative exponent, then we can evaluate. So now from here, 1 over 4 to the third power, 4 to the third power ends up being 64. And we're done our first question. Now another way you can look at that is a reciprocal. So really it is a reciprocal that's happening here, but I like to describe it the way I am so there's less difficulties. Second example, 7 to the power of negative over 2. I'm sorry, I mumbled there. 7 to the power of negative 2. Once again, that negative is telling me that that 7 is in the wrong position. It should be in the bottom. So I'm going to have 1 over 7 squared. Once I've gotten rid of the negative exponent and now I have a positive exponent, I can evaluate. So 1 over 49. Keep moving. 1 over 3 to the power of 1 over 3 to the power of negative 3. Again, we're going to see this negative as a symbol that this power isn't in its natural position. We want to move it to its natural position in order to evaluate. So then that means that 3 has to move up. So I'm going to have 3 to the power of 3. And if you want to write over 1, you can. Now that I have my positive exponent, I can convert it or calculate. I get 27. So you can definitely see these as reciprocals, that once you create the reciprocal, then you drop the negative sign. However you feel like looking at it, that's fine with me. Let's do another one. D. I'm going to say 2 over 5 to the power of negative 4. All right. So the first thing to talk about is this 2. The 2 has an exponent, and it's a positive 1. So if you have a positive exponent, you're in the right position. We're going to leave the 2 alone. The 5, however, it has a negative exponent. So first of all, I'm going to have the 2. It stays in its spot. The 5, it wants to move. It has that symbol for us, so the 5 comes up, 5 to the power of 4. Then I simply can evaluate from there. So 2 times 5 to the power of 4, 625. Multiply those together, I get 1,250, and we're done. Now, if you were thinking reciprocal, it makes sense as a reciprocal, but sometimes students do this. So it was not equal to 5 to the power of 4 over 2. It would not be equal to that. And the reason why is because the 2 has a power of 1. It's happy where it is. All right, we would leave it alone. If you want to use the reciprocal model for this, you'd have to rewrite it. And you'd rewrite it like this. 2 over 1 times 1 over 5 to the power of negative 4. Then again, the 2 has a power of 1. It will stay where it is because it's a positive exponent. This other one, now we'd move this up. The reciprocal would be 5 to the power of 4. So the reciprocal model absolutely makes sense, but so does what I'm saying, hopefully. Let's do some more examples. All right. Now we're going to have a fraction base. So I'm not sure if you remember the exponent rule for this, and in case you don't, I'm going to write it out. So right beside it here, a over b, and I'm going to say to this power of c. So here's just a general rule for you. Whenever you have a fraction base, you simply apply the exponent to both the top and bottom. Okay? So it's going to be a to the power of c and then b to the power of c. So now we can take that knowledge over into our other example. Let's go back to black. So I'm going to have now 2 to the power of negative 2 and then 5 to the power of negative 2. Now they both have negative exponents, meaning they both want to move. So again, we're just going to switch spots or reciprocal, however you want to see it. So I have 5 squared over 2 squared. 5 squared ends up being 25. 2 squared ends up being 4. We are done. F. Let's look at the same type of example, but a different way you could proceed with it. Now in this previous example, if we look over here, we see that we end up really just flipping, right? So we can use that pattern to our advantage. And if you want, you can flip your fraction at the beginning and then make sure that you make your exponent now positive. So I've done the flip right away. I've moved them right away, and then I can proceed as normal. So again, if you have a negative exponent, you can't evaluate. You got to make it positive. So we've done that. Now we can evaluate. So 2 to the power of 3. Oh my gosh, I keep switching pen color. It doesn't want to move for me. And then 7 to the power of 3. 2 to the power of 3 ends up being 8. 7 to the power of 3 ends up being 343. We're done. Let's do one final example. Okay, in this example, we're going to have a decimal base. All right, to the power of -4. So when we have a decimal, we're going to want to convert this to a fraction still. So again, let's just review something. -2.4. We want to convert that to a decimal. To convert to decimals, you have to know the place value of your final digit. So this is the tenths. And because that's the tenths, then that turns this into -24 over 10. And then from there, I can reduce -12 over 5. So to go back to the main question, now that we've reviewed that, I'm going to have -12 over 5 to the power of -4. Okay, and then now we can proceed as same as we were doing previously. One other little detail about this one is I do have a negative in that fraction. So we'll have to talk about that, but I'm going to just kind of flip at the beginning here. And now that's a +4. Now I'm going to apply this 4 to both the top and the bottom. And we have to remember about that negative. There's going to be 4 negatives here because it's technically -5 over 12 times -5 over 12 times -5 over 12. So the way I just deal with that is I'll just get that negative sign. I'll attach it to one of these numbers. So I'm going to say -5. I could have wrote it as -12. So -5 to the 12th power, sorry, -5 to the 4th power over 12 to the 4th power. If you wanted, you could have written it as the 5 being positive and the 12 negative. So one of the numbers have to take the negative. Then I'll keep doing the math. All right, so that would be 625. And then 12 to the 4th power, that's a large number, ends up being 20,736. All right, so if you have a decimal, convert to a fraction. If it's a fraction, we've done a few of those, so hopefully that makes some sense. Before we move on to the negative rational exponents, here's a quick summary of what we've done. To evaluate a power with a negative exponent, we must first express the power with a positive exponent. Once we express the power with a positive exponent, we can then evaluate the power. And yes, I do see this, so I should scratch that out. Okay, so now negative rational exponents. So let's do another example here. And again, our instructional word is going to be evaluate. So it's going to be the same deal where we can't leave it as a negative exponent. We're going to have to make it positive before we can evaluate. Now you might be wondering, what does a negative rational exponent look like? Well, it can look like this, 27 to the power of -2 over 3. So now we're going to be bringing in just our rational exponent knowledge and then the negative exponent knowledge and bringing them together. So the nice thing here, it's always a pattern. The first thing you do is you deal with your negative exponent. So this will transform to 1 over 27 to the power of 2 over 3. Because that 27 has a negative exponent, it's in the top position, that means it wants to move to the bottom position. Once I've done that, then I'll always convert this into a radical. So I'm going to have 1 over the cube root of 27 raised to the second power. Then cube root of 27 is 3 squared, 1 over 9. So we always have those distinct steps. Step 1, get rid of the negative exponent. Step 2, convert to a radical. Step 3, evaluate. Let's do another one. 81 to the power of -3 over 4. Again, let's get rid of that negative exponent first. So it's going to be 1 over 81 to the power of 3 over 4. Now let's convert to a radical. 1 over fourth root of 81 to the third power. Okay, so now you have to determine what the fourth root of 81 is. Ends up being 3, so it's the power of 3, and 3 to the power of 3 is 27, so 1 over 27. Let's keep moving. Let's have now a fraction base again. 25 over 16 to the power of negative 5 over 2. Same steps, everyone. So my first step would be get rid of that negative exponent. So from our previous fraction questions, we learned that a shortcut, a little pattern, is that we can just flip the fraction itself, and then that's what's going to end up happening anyway. So then now this means that my exponent is now positive. And then now from here, I make a radical out of it. So you can do it a couple different ways. You can do it individually. So I'm going to say it's the square root of 16 to the power of 5 over the square root of 25 to the power of 5. Make sure my line's a little bit bigger. Square root of 16 ends up being 4. And then now I still have to the power of 5. The square root of 25 ends up being 5 to the power of 5. And then we get a really big number with this one. 1,024. 6,000. Oh, I can't read my handwriting there. Oh, I'm sorry. Let's erase. Sorry about that, guys. I had a little hiccup in the video. So let me just continue that one off. I had 4 to the power of 5 over 5 to the power of 5. 4 to the power of 5 ends up being 1,024. 5 to the power of 5 ends up being 3,125. All right. Let's do one more example. I've got one more written down here, so let's keep going. 27 over 64. Raise the power of negative 4 over 3. Hopefully these steps have become memorized already. Okay, first thing, get rid of the negative. So again, I'm going to use that little trick we learned previously, that if I just flip my fraction, then that's good. That's like moving everything. So the 64 wants to go to the top, the 27 wants to go to the bottom, so now there's no need for that negative sign. So it's positive 4 over 3. Now I'll convert that to a radical. So I'm going to have cube root of 64 raised to the fourth power over cube root of 27 raised to the fourth power. Okay, cube root of 64. That would be 4. Now raised to the power of 4. And then this cube root of 27 ends up being 3 raised to the power of 4. This ends up being 256 over 81. Here's the summary for the negative rational exponents. To evaluate a power with negative rational exponents, deal with the negative exponent, so that's perform the reciprocal, move it however you want to do it, convert the power to a radical, then evaluate. I hope this helps everybody. If not, make sure you contact myself or a teacher. Good luck.